is 0.37. I'm taking notes and then I'll stop sharing.
Okay.
Are the people who answer yes to the question? Are you in favor of death penalty for a person convicted of murder? Okay, so the margin of error is 0.05.
For me, it was 2%.
Okay, then I'm going to change it to 0.02. And the estimate was made with, did you have 96%?
Mine was 95%.
95% confidence level. Okay, at least how many people were surveyed? Okay, perfect. Okay, so for 95%, I can stop sharing again. How do I determine the Z score, right? So we go to inv norm, second and distributions, inv norm. So scroll, just press 3. And the area to the left, as you, of course, let me show the whole thing again. So by 95%, we mean the middle is 95. So this total in the tails is 5%. So obviously this is 2.5%, which is 0.025. And of course, the same thing here. They are both the same. So in order to determine this or this, depending on which one, it doesn't matter, they will be the same. One will be with minus and the other one will be with plus. And these numbers should come easy to you now. It's 1.96, but you don't have to remember it, right? I'm not asking you to memorize this. So we go to the area, which is 0.025, and the standard deviation has mean 0 and standard deviation 1. I mean the Z standard normal. And we get that 1.96, either positive or negative. So this is the first thing we have to determine, right? So remember what margin of error is. The margin of error is Z, that Z alpha over 2 is this, or this. It doesn't matter. We're going to use the positive, right? And this is the square root of p hat 1 minus p hat divided by n, where p hat is this. So this will be 0.37. This will be 1 minus 0.37, which is 0.63. And n is what we are trying to determine. We have this, we have this, we have this, we have this. What we don't have is n. Okay? Now we can go directly to the formula or just watch again how it's very easy. Square both sides. E squared equals Z. This is Z sub alpha over 2 squared. And then we have P hat 1 minus P hat divided by N. All I have to do is cross multiply. Switch these two places, and that's it. So then, or you just remember the formula from the beginning, or you keep it in your notes. So I have Z squared P hat 1 minus P hat divided by E squared. So this is the formula. So what I plug in is Z 1.96 squared times P hat 0.37 times 1 minus 0.37, 0.63 over the margin of error, which is given to us as 0.02 squared. Put this in the graphing calculator. Because the denominator has only one term, you can put it as this times this times this over this. But if I have, I'm going to erase it, don't change anything. If I have something like this, I have to have parentheses around the top and around the denominator. Okay? So please keep that in mind. So it's better to put them so you don't forget. Okay, so I'm going to share my screen now. And I have left parent 1.96 squared times 0.37 times 0.63 and close, divide. I'll put that in parentheses as well so we get used to it. No, 0.02. Okay, squared, close. And this is the number of people or individuals we have to survey. If there is anything after the decimal point, we have to go up 1, no matter what it is. So 2238.6 means 2239. Even if this were 0, this digit, the 10th digit were 0, I would still have to go to 2239. So 2239 9 is the sample size. I have to survey 2,239 people to meet my target of the margin of error of 0.02. Oh, I didn't mean to do that. I meant to do this. Okay, so we had examples in class about this. Where is my keyboard now? Okay, here it is. 2239. Oh, I can't put my number. Sorry. I can't put this in. It's going to be wrong because I changed 5 into 2 and the 95 into 96. So I can determine it with the numbers I have, though. The 37 is the K, so the denominator was 0.05. And for 96, I don't know what is Z for 96. So let me check Z for 96. So inf norm for 96 is 2 and 2. So this will become 0.02.
Is there a way that we can get this in Statcrunch?
Yeah. Yeah, I showed that too. So let me finish now because do you need another part or do I have to complete?
Oh, no, you can finish this one. I was just curious.
No, my question is, do you need another part of the question or this is it?
Oh, that's it.
Okay, but then I don't need it. I don't need to put in my number. I just wanted to help you and everyone else with the problem.
Thank you.
Sure, my pleasure. So is there another question here or is this enough?
That's it, but would you mind showing how to get the same answer in Statcrunch?
Yes, no, I don't mind, of course. Give me 1 second to see how I get there. How do I get there?
If you click get more help, it'll give you the Statcrunch link.
Oh, it has to give me the Statcrunch link here from the manage the course too. Okay, so let's see. We know how to determine probabilities. Let's see if we can determine the inf norm. I showed that last time. If you remember, you put the probability. Okay, we want T, no, we want Z stats. Just 1 second. Okay. Okay, so what do we want? You mean the sample size? No. If the question is about the sample size, the answer is no.
Yeah, I think it was about the sample size.
No, you have to use the formula. No. But it gives us the z-score if you want. So if I want the area to the left to be, if I want the area to the left to be 0.02, it will compute that number that I came up with, right? The negative 2.053, this number. So that I can determine, but not the sample size, no. You have to use the formula for the sample size, yep. Other questions for me? Very good question. Thank you, Maddie. Other questions? Did we have anything else? From anything else? From homework? From
Would you mind lowering the notes? I can't see the top. I was trying to see something.
you mean this?
Mm-hmm. If you don't mind me asking, where did we get the 0.63?
1 minus 0.37.
Okay, thank you.
You're welcome. Good. Anything else? Other questions? Are we all ready then to continue with 9.2? Point estimate, so 9.2. This is the same with what we did, but as X bar. And we are going to talk about something called T distribution. So we're going to find Sample size, we're going to find point estimate. We're going to find interval estimation of the parameter mu. In 9.1, we are looking at the parameter p, population proportion of people with such and such. But now we're looking at the average or the mean, population mean. This is the parameter, and we're estimating it with a point estimate, and we're going to be able to also find confidence intervals. Okay, so last time after class, Monday after class, I looked at the grades and where everybody is, and some of you were not finished with chapter 8. I did not check the situation today. Please don't drop the ball right now because we are down to 4 weeks, and this part of the course, the inferential statistics, is more intense. It has more ins and outs, and we need more time. So please don't fall behind, okay? Any questions maybe from chapter 8? That's why there were not too many questions on Monday on chapter 8. And when I looked, I said, oh, that's why my students didn't get the chance to finish. Any questions on 8 or 9.1? Okay, I don't hear anything.
No, ma'am.
Okay. Good. So now let's talk about the point estimate for mu. And we remember from chapter 8 that x bar is normal with mu and sigma divided by the square root of n. So if we have a distribution x that is normal or approximately normal, or the sample size is greater than or equal to 30, so it's normal or sample size is greater than or equal to 30, so this will be mu and sigma, then the sampling distribution of the mean is always normal, if it's normal or at least 30, with mean, the same mean, with the population mean, and sigma, the standard deviation, much smaller. How much smaller? Divided by the square root, the same thing, but divided by the square root of n. Of course, this is much bigger than this. Okay. So now we're continuing with analyzing the fact that x bar is a point estimate, which we already know, of population mean, denoted by mu. And this is the first way of estimating mu. The second way is with a confidence interval. Like we did with the proportions. And the confidence interval is exactly the same concept, plus or minus the margin of error. Of course, it's a symmetric interval. So x bar minus the margin of error and x bar plus the margin of error. Okay, so now how do I determine the margin of error in this situation? If I know that the underlying population is normal, I will immediately use z alpha over 2, and I will have s sample standard deviation divided by the square root of n. Now, what happens is, because we do not have the sample, the population standard deviation, this distribution, which we know is the standard normal, what does it equal to? We know that from a long time ago. X bar, I'm sorry. So it's x minus x bar divided by the standard deviation. And since I used x bar, I'm using the standard deviation for the sample, or the same thing, z equals x minus mu divided by sigma, right? This is the standard deviation, and the standard normal, and we know that it's normal with 0, 1. But the thing is that we do not have the standard deviation of the population. So this, to be on the safe side, will be replaced by another distribution, which is t. T distribution. T distribution looks like z. What does that mean? It looks like this, is centered at 0. It does not have standard deviation 1. It does not. So let me use sigma this time. Sigma is not 1 like it was for z, right? 0 and 1. It's still centered at 0. The area underneath it has to be 1 because it's the probability. Maximum 1. It has a little bit wider tails than the z distribution. Still symmetric. However, it depends. It has a slightly different shape for different degrees of freedom. Now, let me refresh your memory where this is coming from. We mentioned this a long time ago when we looked at sample standard deviation. Okay, so we said that the sample standard deviation was determined with the square root, the sum x minus x bar squared divided by n minus 1. And at that time I said, be very careful, because the calculator gives us two different numbers, even the Statcrunch, remember? Standardized or not, right? So, or polled or something, it's called in Statcrunch. So n minus 1 is exactly what we call df, degrees of freedom. When we determined the population standard deviation, we divided by the entire population and we did not subtract 1. So the numerator is the same thing. Of course, I have to use mu here. I have to be careful with notation. I don't want to confuse you. If I use sigma, I have to have mu and n. If I use s, I have to have x bar and lowercase n. We know that. Very easy to forget the notation. Okay, so of course, if you compare these two, this must be the smallest of the two. How come? Right, because here I divide by n and here I divide by a smaller number. So if I have between 1/2 and 1/3, of course that this is smaller. I divide a cake to 3 people instead of I divide a whole cake to 2, right? So that's where the degrees of freedom are coming from. So when we look at this t distribution, we will always have to write degrees of freedom. 2, 5, 10, 15, 20, whatever that is. So the t distribution has a minor difference in shape for different degrees of freedom. That's where the standard deviation is different for each. So here I will always say standard normal is a normal distribution with mean 0 and standard deviation 1. I cannot say that about the t distribution. I can say for sure that the mean is 0, but it depends on degrees of freedom to determine the shape or get the shape. It's not different, not very different from the standard normal. And also, as n increases, let's say to infinity, of course, you know what I mean, increases, t distribution gets closer to the z distribution. So if n is like 500, it doesn't really matter, most likely, if you use z or t. But if n is 10, it's a huge difference between t and z. You have to use t to estimate. So then the confidence interval, let's say 95% confidence interval, will look like this. So x bar minus t alpha over 2 for 95, and then s divided by the square root of n, and of course x bar plus t alpha over 2 s the square root of n. So this is what we want to do today. And if we finish this, all problems or most of them, then we can continue with the next step. What is the next step in this class? Hypothesis testing. And this is the last item that we need to look at. For one population and for two populations. And that will be the end. 10 and 11 deal with this. 10 deals with one population proportion and one population mean, and the last chapter deals with two populations for proportions, two populations for the mean. And that would be the end of the course.